Welcome back for another Feature Friday. I'm your host, Ryan Glover, and this week we're going to be talking about unit tests. And we're going to see why unit tests don't have to be scary and why they're actually important for a functioning product. But we're also going to look at how do we actually write unit tests. So what we're going to be doing is working with Jest, which is the combination test runner and test framework that's used inside of our boilerplate pup that we use with mentees at Clever Beagle. So what we're going to do is break down a module that exists inside of pup, and we're going to actually work out how to write a unit test for that, and we're also going to work out what does it look like to run those unit tests, and then talk about some philosophy around why do we even want to write unit tests in the first place. Before we get started today, I want to remind you to head over to cleverbeagle.com/pup and download a copy of the boilerplate that we're going to use for this tutorial, and we also use with mentees at Clever Beagle. It gives you everything you need to start, build, and ship a product, including all of the wiring you're going to need to do unit testing in your own product. Before we dig into writing tests, what I wanted to do is show you the code that we're going to be writing tests for. So what I've got in front of me is the dates.js module in pup. And the dates.js module is just a collection of helper functions that help us to format dates in our product. So instead of displaying messy, computer-friendly strings on the screen that our users aren't really going to understand, the dates.js module contains functions that help us to format those date strings in a way that's going to be more friendly or more easy to read for the users of our product. And what we're going to do is write unit tests for each of the different functions inside of this module. Like I hinted at the beginning of this video, what we're going to do is use the Jest framework from Facebook for writing our tests and running our tests. And in order to get started working with Jest, what we need to do is create a test file that Jest will automatically detect when we run Jest from the root of our project. And it's going to see whatever tests we write, and it's going to try and run them for us. So in order for us to create something that Jest can see, what we need to do is go over to modules, and we're going to create a new file called dates.test.js. And inside of that file, what we're going to write is describe. And describe is a method that's globally exposed to our application by Jest when Jest runs our tests. So there's nothing for us to import from Jest directly here in order to get describe. And what describe is this is declaring what's known as a test suite for a given file in our application. So here we're saying dates.test.js. So we're telling ourselves that, okay, these are the tests for dates.js, this file right here. And so when we're saying create a test suite, we're saying create a collection of tests or a suite of tests that are related to the code that we're testing. So in this case, this is a collection of tests that are going to help us test dates.js. The empty string that we can see here is what we're going to use to name our test or identify our test. So this is just for us as developers, but it's helpful to give it something that's very, very clear about what this suite or what this collection of tests is actually testing. So here what I'm going to do is write the name of the module that we're testing. So I'm going to say dates.js. And again, this string or this name is just for us as developers. So what we'll see in a little bit when we run our test is that Jest is going to identify the test that it's currently running or the suite that it's currently running using this string. So it's going to output dates.js to the terminal when we run our test. We'll see that in a little bit. So what we're going to do now is add one test, and we're just going to add a dummy test to get started to our suite. And so there's a few different ways to do that, but what I like to use is the test method. And again, just like we saw with describe up here, test is a global exposed to our code by Jest when Jest runs our test. So again, there's nothing for us to import. It's just exposed to our code. We don't have to do anything else. And what we're going to do is pass a function to this, just like we did with describe. And the difference between the two here is that dates.js up here, describe dates.js, again is declaring our suite, whereas test is saying this is one test inside of this suite. So just to make this clear, if we duplicate this, we're going to have multiple tests inside of this file by the time that we're done. And so what we're going to do now is write just a dummy test. So we'll say 1 equals 1. And the idea behind tests, and specifically unit tests, is that we're trying to determine whether or not a very small chunk of the code in our application works the way that we expect it to work, or works in a way that when we use it, it doesn't give us any surprises in terms of its behavior or what it does or what it returns to us or things like that. And in our case, when we're measuring or when we're testing dates, what we want to do is verify that given some string, so given some random date string, does it format the string in the way that we want? So does the function that we import from dates.js, does that function actually format the date in the way that we want? So before we get into that, what we're going to do is just write a simple test that's going to help us to see how a test works and what are the different things that are making up a test. So the very first thing we're going to do is we're going to say, let's write a simple function in here. And this simple function, let's move this outside of our describe block. So I'm just going to write a function called add, and we're going to say n1 for number 1 and n2 for number 2. And then all this is going to do is add two numbers together. So we're going to say add is a function that says n1 plus n2 and returns the value. And here we're going to get an implicit return, and that is when we have a function that does nothing else but return. So I could write this like n1 plus n2, but we don't need to do that. We're just going to use the implicit return and say, hey, only thing we're doing inside of our function is returning a value. So JavaScript is smart enough to interpret this as that. So down in our test, what we want to do is we want to say answer. And answer is just a variable that I'm coming up with. So this is just something that we're going to use next to evaluate whether or not our code is working. So we're going to say, okay, add 5 and 10. And so what we expect, and this is where we're starting to get into the actual test that we're writing. So we're going to always write some code, and then we're going to verify that it works in the way that we expect. So a lot of the naming here is very direct and obvious. So we're saying we expect answer to be. And here we have what are we expecting, and then we have a method that we can use to compare that value. So we're saying this is the expected and this is the actual. And so what we need to do, or actually that's backwards. What we want to say is this is the actual. So this is what we got back from our code, and this is what we expect it to be. So in this case, we're saying answer should be 15. Now, I've saved this code, but we really haven't seen how this comes into play or how this works. So what I'm going to do is jump over to my terminal. You can see I've got a copy of pup running here. We don't really need to worry about that too much. So what we're going to do is go into our terminal. We're inside of the unit test directory. So this is my copy of pup that we're using for this tutorial. And what I'm going to do is run an npm script called npm Run Test. And what this is going to do, you'll see it's calling to Jest, and this is going to find all of the test files inside of our project and run them with Jest. And you'll notice that what it did was it ran all of our tests, and it told us, okay, everything seems to have passed, and it took 3.2 seconds, and then it exited. And it exited because I used the version of Jest where it's not going to watch our project. All it's going to do is run our tests and then exit. And most commonly, this is used when you're doing continuous integration or something where you really do just need to run your tests once and then exit. So in this case, this isn't really helpful for us while we're doing our active development work, but it is helpful for something like continuous integration. So what I'm going to do is run this again, but I'm going to change my command and I'm going to say npm run test watch. And just to make sure this is clear, npm run test and npm run test watch are built into pup. So those are already wired up for you, and you can just run them directly in pup once you're all set up with the project. So you'll notice here I ran that, and it's saying one passed, and one test suite passed, and one test passed. So what's interesting about Jest, and what's actually quite helpful, is that Jest is a little bit self-aware. So it knows what code we just recently changed, and it's paying attention to that. So it's not going to necessarily run our entire test suite at once. It's only going to change the code that most recently changed in our project, or it's only going to test what most recently changed in our project. So you can see here that ran, and now it's just kind of waiting. It hasn't exited, it's just waiting. So what I'm going to do is change this, and we're going to break this. So we're going to say we expect 5 plus 10 to be 10, which we know is not true. And we can see if I jump back over, Jest has already rerun the test, and it's telling us, hey, what I expected or what I received does not match what I expected. And so here it's saying, hey, something's wrong with your code. So in this case, what this is saying is, hey, you probably need to fix your code in some way. For whatever reason, it's not adding the two numbers together correctly. So in this case, we're just fudging it. We're just breaking this on purpose. So again, if I save it and we jump back, we can see that, hey, our test passes. Now, if I break my code for some reason, so I'll say instead of adding it, it does n1 minus n2. So it's subtracting instead of adding. We can see that this breaks. But the point of doing this is that, well, one, it shouldn't break, and two, this is telling us as developers, hey, something's not right with your code, you need to fix it. And so this is the whole point of tests, and specifically with unit tests, this is helping us to verify that one tiny little unit or chunk of our project is working the way that we expect. So in this case, we want to be able to import the add function anywhere in our application and have it work. And if our test is failing, that tells us that, hey, we can't comfortably import that function into another project or into another file in our project and actually use it consistently. So this is telling us, hey, you need to look at the code, and sure enough, we need to change that to a plus, not a minus. And if we jump back, we can see that our test passed. Now that we've successfully seen how to write a test and how to get a test to pass, what we want to do now is actually test the real code in our dates module. So what we're going to do is get rid of this add function up here, and we're going to replace this with an import, and I'm going to say import star as dates from /dates. So what's happening here is we're saying /dates, meaning the dates file that's immediately relative to the current file that we're in. So we're just saying look in the same directory as the file that we're in right now, meaning dates.test.js, and give us the dates.js file. And here I'm not including the .js because .js is assumed in this case, and so we can just say dates and JavaScript will know how to parse that. And then over here what I'm saying is import star as dates. So if we look back in our dates.js module, we can see that all of our exports are using the named export syntax, which means that when it comes to our code, typically what we'll do is import named exports one at a time. And that module is designed that way because each of these date functions isn't meant to be used all at once together, but rather in the certain place that you need it in your UI. So for example, with the month, date, year function here, if we want to format a date in our UI using this format, we're only going to import that function. We're not going to import, all of its sibling functions at the same time. So back over here, what we're going to say is import star, meaning give us everything that's exported by a name there. And we're going to say combine those into an object called dates. So now I can say dates.month, day, year as opposed to having to reference month, day, year directly and confuse myself inside of my test. And it also saves us quite a few lines of code because we're not going to have to type out those imports as we go. So now what we want to do is convert the code that we were testing before, which was just our example 1 = 1 test, and we want to actually write a real test for some of the code in our dates.js module. So what I'm going to do here is write a unit test for this month, day, year function. And what we want to test is that if we pass a timestamp here, and this is going to be a computer-friendly timestamp, so one that we would put in our database. If we pass that computer-friendly version of a timestamp, do we get back a formatted timestamp or a human-friendly timestamp like we'd expect? So what we're going to do back here is change the name of our test, and we're going to change this to month, day, year returns a formatted date string. And then instead of answer here, I'm going to convert this to month, day, year string. And then remember, we have all of our functions imported on that dates object. So I'm going to say dates.month, day, year. And we're going to get rid of these arguments from before. And we'll just put an empty string in there for now. And then we're going to copy month, day, year string and make that our expectation. So we expect this month, day, year string to be some other string. And what we're going to do to help us out is jump over to the browser, and you can see here I've got a copy of pup running. And down in my console, I'm just going to tell Chrome to give us a ISO string. So an ISO string is a internationally recognized date format. So this is the ISO 8601 standard for formatting dates. And what we can see here is that this is giving us back a date string that's saying, okay, the current date and time is November 30th, and we can see it's in 24-hour time. So this is saying 1800 hours and 3 minutes. Now, if we look on the end, it just says the letter Z. And what this is denoting is that this date string is in UTC or GMT time. So this is not relative to me. So right now I'm in Chicago, so I'm GMT minus 6 hours, whereas this date string is relative to GMT time. Now, we're going to leave that as is because technically speaking, or typically, what you'll find is that it is good to store your dates in UTC or GMT time. So this is going to be a little more in line with how we would expect our code to actually be used. So it makes sense to write our tests against data like that. So what we're going to say here is, if we expect the date here going in to be November 30th, and this is 1800 hours and 3 minutes, this is 6 p.m. roughly, what we're going to say is if we go into month, day, year, our function here, we're going to say, okay, if given that time step, we expect it to return to us month, day, comma, year. And so right here, if we type this out, we're going to say we expect the month to be November, and we expect the day to be the 30th, and then the year to be 2018. So if we go ahead and save this, and then jump back to our test, we can see that our tests are still passing. So if we come back over here, and we'll just break this on purpose, I'm going to change this to November 31st and save it. We can see that once our tests run, it fails because it's saying, hey, I expected November 31st, 2018, not November 30th, 2018. What's great about this is that this is giving us immediate feedback about whether or not our code is functioning as we expect. So here, because we have a failing test, this is telling us that, hey, either something we're testing is incorrect or our code is incorrect. And so in this case, we know that the test is incorrect because we deliberately changed the date. But if I save this and go back, now I'm getting a pass test. So this is telling me that, hey, your code is working exactly how you expect. Now, it's very possible to get false positives and false negatives when you're writing tests, but generally speaking, this is a good thing. So because we're getting a green light on this code, given that with these inputs, or with this input, we're getting back this result as we'd expect, that means great. Our code, at least given those inputs, is working as we'd expect. Now, what's great about this is that now we have a passing test in our test suite. So what we want to do is take this a little bit further. So if we go back to dates.js, we can see that the month, day, year function takes a second argument of time zone. So what we need to do is test that when we pass a string, a date string, and a time zone string, we're actually going to get back the date that we expect. So what I'm going to do is duplicate this test. I'm going to change this title for the test slightly. So say month, day, year returns a formatted date string relative to a time zone. And because we're doing this relative to a time zone, and we know that our date string is based in GMT time, so this is saying November 30th, again, this is 1800 hours or about 6 p.m. GMT. Because we know that this is November 30th, we want to pass a time zone that's actually going to augment this in a way that's very obvious to us. So what I'm going to say is I'm going to pass Asia/Hong Kong. And this string that you see here, this is known as the Olson database version of a time zone. So there's an entire database of time zones that exist in the world, and they're denoted by the country or region name slash, typically it's some city or some GMT offset. So here I'm saying, let's take a place that's on the other side of the world and use that as our time zone, because what that should do is bump this time zone or this string into the next day. So in this case, we should get December 1st, 2018. So if we go ahead and save this and then jump back to our test, we can see that that's exactly what happens. So we expected November 30th, but we got December 1st, 2018. And that's because, again, we're saying convert this date to a time zone that's technically in the future. So it's already tomorrow in Hong Kong. It's about 2 a.m. So now we know that, okay, this date should be tomorrow, not today. So if we say December 1st, 2018 and save it, see that? Great. Our test pass. And so what that means is that this code is working as expected. So it works with the use case of just passing a single string and getting a date back, and it also works relative to a time zone. It's important to point out here that this test may seem deceptively simple, But because we're focused on writing unit tests, this is a good thing. Units, by their very nature, should be a small chunk of code. So that should be a single function in our application, like we're seeing here with the month, day, year function. So it's a part of a module called dates.js, but this one function is a single unit in our application. So it's not really dependent on any other code in our application. It's only concerned about itself. So when we write a unit test, the test itself should be simple. If we have a bunch of code just to test our actual code, so meaning the test code is longer than the application code, generally speaking, that's going to mean that, hey, something's not right about this, and we either need to refactor our test code or we need to refactor our application code to make sure that, we're not pushing things further than they actually need to be pushed. So now that we understand how to write tests as part of a test suite, and we've seen how to both fail tests and pass tests, what we're going to do is keep moving with this pattern. We're going to write one more pair of tests for the month, day, year at time function here in the dates.js module. So what we're going to do is copy this first test, and we're just going to bring it down here, and we're going to change this to, instead of month, day, year, we're testing the month, day, year at time function. So I'm going to say month, day, year at time, and we'll say month, day, year at time string. And then right here we'll say month, day, year at time. And let's copy this down to our expectation here. So we're saying expect month, day, year at time string. So one thing that I'd like to point out is that we have a little bit of repetition here with this string, our date string. So what I'm going to do is copy this string, and I'm just going to scope it to the top of this file. And this is a good thing to do. So whenever you have data inside of your test that's being reused, it's really worthwhile to consider just creating variables with that data and then reusing those variables. So that way you're not having to copy and paste the same exact thing, and you're not breaking the grand developer rule of dry or don't repeat yourself. So now what we need to do is actually build out our remaining tests. So if we look back over here in our test, we can see that, okay, everything's working with that date string, but our new test is failing as expected because we haven't passed the correct string. So what we can see back here is that this module is returning, or this function in the module is returning, a date string with the word at, followed by the hours and minutes and the meridian, so AM or PM, of that date and time string. So back over here, we're expecting this to be, we can see here, this is 1600 hours, or 1800 hours, 6 p.m. And so what we need to do is say, okay, we expect that string to be November 30th, 2018 at, and I'm going to say 6 p.m. Now, you may have noticed a few seconds ago that this is going to fail. And so, and let's make sure that's very specific. So we should do 06:03 p.m. So I'm going to save that. We can say, okay, the discrepancy is that what we're receiving is 12:03 p.m., but we're passing 6:03 p.m. And I did this on purpose. So this is technically, this date string is technically 6:03 p.m. GMT, but remember, this video is being filmed in Chicago, so this is 6 hours behind GMT. So when our tests run, they're going to be run on this computer whose time zone is set to the Chicago or Central Standard Time zone. And so whenever I get a result back from my test, what's happening is it's saying, hey, wait a minute, this time is not correct because I expect it to be relative to the time zone where this is running. And this happens for a very specific reason. So whenever you're dealing with an ISO string where the time zone is not specified, or the offset, so in this case, for Chicago, it would look something like this, minus 6 hours. Because we don't have that on there, we just have the Z, what's going to happen is the computer is automatically going to convert that time relative to the computer where it's being viewed or where it's being utilized. So in this case, because we're utilizing a UTC string on a computer whose time zone is Chicago or Central Standard Time, what we're going to get as our result is this function is going to convert this relative to the computer that we're on, not relative to the exact time zone of the string itself. So what we're going to say here is, instead of November 30th at 6:03 p.m., we're going to say 12:03 p.m. because I'm 6 hours behind GMT, and even though our string is GMT, it's being converted by my computer to my local time, which is 12:03, not 6:03. So if we jump back over to our test runner here, we can see that, okay, we've got a little bit of a bug, and it's very subtle. So this is good and bad at the same time. So we can see that we expected November 30th, 2018 at 12:03 p.m., and we received November 30th, 2018 at 12:03 p.m. But notice, we're expecting a capital PM, but we're only getting lowercase pm. And now if we look back at our code, what we can see is in dates.js, per the formatting rules of the moment package, a lowercase a gives us back the meridian for our time and date as a lowercase pm or am, not capital. So technically speaking, if we wanted this test to pass as it's written, meaning our test is the truth, that's what we actually want. If we convert this to a capital A, and then we jump back, we can see that, hey, our test passed. So those are the sorts of things that will come up while you're writing your own tests relative to your own code. And it's helpful to use your test as a way to inform the design of your own code, because your test, if you're writing your test in a way that you're saying, this is what I want, then what you're doing is you're testing first. So this is known as TDD, or test-driven development. So you're saying, I want this to happen first. So I want this to happen being what you write in your test, and then you write your code to actually make that happen. To wrap up, what we're going to do is focus on writing one more test, which again is the time zone specific variant of our month, day, year at time function. So we're going to say month, day, year at time returns a formatted date string. Just like our other test, we're going to say relative to a time zone. And what we're going to do, just so it's not terribly confusing, what I'm going to do is, instead of Asia/Hong Kong as the time string that we're going to use, what I'm going to do is say something that's a little closer to me. So I'm going to use Eastern Standard Time to format this time string. So I'm going to say America/, and then we're going to change this with new_York. So that's going to be an hour ahead of where I am in Chicago. So if we take this and we format it, again, date string here, this variable, is coming from up here because we said we're going to reuse that date string in every test, so let's just put it in a variable. So we're going to say that date and time should equal 12:03 p.m. Now, we're purposely going to fail this because we can see that, hey, because we're putting this in America, New York, or Eastern Standard Time, that's an hour ahead of Chicago, which is 1:03 p.m., not 12:03 p.m. So if we come back over here, and we're going to say, right here, we'll delete this, we'll say 01 or 1:03 p.m. and save it, we can see that, okay, we get another error. And this is because our test, again, is getting caught on the capital versus lowercase version of the meridian. And so this is great. Technically, we would have expected our code to behave in that way, but we can see that based on the way this function is written, it's saying if a time zone is not passed, use this function to do the formatting, and if a time zone is passed, meaning the inverse of this, use this function. And we can see that these two are using the exact same string, or should be, but this one still has a lowercase a, even though this one has a capital A. So I'm going to change this to a capital A, and then we're going to let this run again, and we can see that, hey, our test passed. And with that, we're going to wrap up Feature Friday for this week here. So we've got a passing test suite with 4 passing tests, and we can see that in terms of coverage in our code, we've got 2 functions being tested with 2, so we've got month, day, year being tested and month, day, year at time being tested with 2 tests for each function. Now, in terms of coverage, because we have quite a few more functions inside of dates.js, technically our work isn't done. It is for this video, but not in general. So I'm going to have to come in here and write quite a few more tests to make sure all of these functions are validated as working. But in this case, we're just going to stop here. Now, before we wrap up, it is important to note that the amount of coverage, or the amount of testing that we do for our code, is completely contingent on the code that we're writing. So in this case, I've decided that, hey, as long as I get back a date string formatted this way and a date string formatted this way using a time zone, and the exact same thing for month, day, year at time, I'm a happy camper. Now, you, and if you're working as part of a team, you may have different expectations as to how many tests you need and the different permutations that you want, or the different permutations that you want to test for your code. So that all depends on what you're doing. So a good rule of thumb is to write tests that test your code in the way that your application code actually uses it. So it's really easy to say, well, I want it to throw a bunch of errors if I don't pass the certain arguments, which if we wanted to be excessive about the design of these functions, we could add, validations to this code and say, well, come in here and we'll return this, but then the actual code is going to also check its arguments. We'll say, if not timestamp, throw error. I'm not gonna finish that out, but we're just gonna do it as an example. So we could go that far, but that again depends on the needs of the project and the needs of the application that you're building. So if you're fully in control of the code and where that code's going to be used, generally speaking, you can be a little less stringent about things like that. But say you were designing a third-party library that other people are going to use, so you were creating something like an NPM package, then you want to be a little more fussy, because once your code is out in the wild, you can't really control how someone's going to use it. So at that point, you want to be a little more stringent in your tests. So with that, that's going to wrap us up for today. I really appreciate you watching. Again, if you've been watching these or following these, make sure to hit the subscribe button on YouTube, because it helps us out to know that you're interested, and it also makes sure that you get our latest episodes every single week. And if you're really into these, make sure to tap the bell icon so that you get notifications as soon as we publish these. So with that, I'll see you next week, and we'll be talking about integration tests. So we're going to take this stuff a little bit further and see how we do integrations between different parts of code in our application, as opposed to isolated units like we saw today. If you enjoyed this tutorial, I'd really appreciate it if you head over to cleverbeagle.com/subscribe and sign up to get our latest tutorials and advice in your inbox as soon as they're published.